implementation of a binary search tree in C. The language is not that important. What's important is you understand what a binary search tree is and the advantages it gives you. A binary search tree is a data structure where the data you store is kind of like stored in a kind of an ordered way. For example, this data is the data of integers. And as you can see, the parent node, if you look at the parent node on the left and the right side, the parent is more than the left side, but less than the right side. And this structure like follows. Even here, like 60 is more than 40, but less than 80. 200 is more than 150, but less than 250. So what advantages does this give you? Because you know that what's on the left is less than what's on the right, and the parent, you can, if you're looking for like 50, you can traverse this data structure by just saying, okay, I'm looking for 150. You start at the root, which is the parent, 100. You know 150 is more than 100, so you go to the right. You know 150 is less than 200, so you go to the left. So this ends up giving you a search traversal of log of n. That's a good advantages. But there are also different ways of traversing a binary search tree. There is a PreOrder, InOrder, and PostOrder. What does that mean? If I want to traverse the binary search tree in order, that means I'm going to go in order. I'll start with 40, 60, 80, 100, 150, 200, 250. And the way we implement that is we go to the left node, then the root node, then the right node. But if you're doing pre-order, you start with the root node, you go to the left node, then you go to the right node. But if you're doing post-order traversal, you go to the left node, then the right node, and then the parent last. All right, now let's start implementing this data structure in C. Let's see. I need a file. I'll just use main for this. Okay, and what are some of the things that I need to have? In C, I need to bring in some standard libraries. For example, standard IO, which is going to enable me to print stuff. And because I'm going to be like allocating memory myself, I need to bring in the standard library for that. And let's set up the main function. I'm not going to be receiving any arguments here, so I'll just put in void there, and then I'll return 0. And just to make sure that the program is working, I'm going to just print the regular hello world, just to make sure that I've not made any errors. And then I'm going to quickly compile this program. And I'm going to just output, I'll call it binary search tree. Okay, so I just made an error there on printf. All right, compile, and I'm going to run the binary search tree, and we see hello world is coming through. So we're in business. So what do we need? We need some way of storing those three, like so we need some kind of like a node that's going to kind of like also store like the address to the left side and the right side. And with the unexpected data in there. So in C, I can store that using a struct, and that's what I'm going to use. And I'm going to, instead of typing node struct all the time, I'll just define that data structure for myself. But since it's also going to use like the node inside the struct, I need to give it a name there. I'll have the data with starring integers in this case. So I'm going to do that. And I'm going to point to the next node here. But it's just going to point to the pointer address of the next node. And do the same for the right node. And then, as I stated, I don't want to be typing struct node all the time, so I'll just give it the name called node here. All right, so we do have our struct in place. I'll close that so we have more screen. So what are the functions that we need? We need to be able to make a node. We need to be able to insert into the node, and we need to either search a node or print pre-order, post-order, or InOrder traversal. So what am I going to start with? I'm just going to like write the functions body, and then I'll start populating them. The first one is a new node. That's going to return an address to the new node. And the only thing you're going to get in here is an integer, pretty much. All right, and which other functions I need to be able to insert into a node, but I'm just going to return an address to the node, and then I'm going to feed it a node itself. So I'm going to pass in the address of the node I'm on, and also the value that I'm trying to put into this chain of nodes. Okay, so we have that function. What other functions do we need? We need contains, and this one is going to return a Boolean, but in C, since we don't have a Boolean in C, I'm going to use an int 0 for false and 1 for true. And the same thing, I'm going to pass in the node in there, a pointer to the node. So pretty much I'm just passing in addresses through and through. What else do we need? We need those traversals we talked about it, and those are just going to be printing out like wherever you are. And I'll just quickly write this one. I'm actually going to start with those because it's pretty much just doing the printf, but printing in different order. So I'll start with the print in order, and obviously it's going to receive an address to the node. And but instead of just saying a node here, I'll specifically call it a root, because we are always going to start from the root whenever we are traversing. And the other thing I'm going to do is I'm going to check that the root is not equal to now. If it's not equal to now, then I'm going to traverse this and print it out. And in order, we print the left side off, and then we go to the right side off. And then we're going to print that just recursively. So we're going to pass the left side there, so that this will be recursively printing the left and then it's gonna print the root, the data itself. And in this case, we're printing integers. So I'm just gonna use %d, and we're gonna get the value of that node, and then we're gonna print to the right side. Print InOrder to the right side of the node. All right, so we're going to do the same thing for this with the other way of traversing this binary search tree. So I'm just going to copy these and paste them twice. And the other one is printing PreOrder. Just change the name. And then if I'm doing PreOrder, I just need to change when I print the data there. But everything else remains the same. And obviously, that recursive function has to change too. And then the other one is PostOrder, which will obviously change those two. And then we'll print that one last. Okay, so the printing function is done. So we can now go back to the new node. So what do we need to make a new node here? We'll need to allocate some memory here. So I'm going to initialize a variable. I'll just call it a node, and then I'll give it some memory using malloc. And I'm going to use the size of the node itself. And then I'm going to return node itself. All right, now just to make sure that everything works all the time, I'm going to cast this to make sure that I'm actually casting it to a node. All right. And then we have this value here we need to put into the data. So we're going to assign data the value we're receiving there. And then we're going to, I'll go with the strategy of making all the other nodes now without relying on C to make sure that the left and right side are now, because I have to make sure that they're literally now. So the left and the right, I'll make them now. Right, so we have this node created. We've initialized the data, and the left and the right are now as a new node. All right. So the first thing is I'm going to go into the main function itself, and I'll initialize just a node there, and then I'm going to insert. I'll use the insert function, and then I'll use the insert inside the insert function. I'm going to create a new node using the new node function we just created. And I'll call this one a root. I'll initialize it to now. And I'm using a pointer here. And then I'm equating that to passing in that pointer. And in this case, we want to match the drawing we had, so I'm going to start with 100. All right. And then once we have that, I'm going to go into here. So we're receiving that node we have here with the value. And the first thing we're going to do is check if the node we're receiving is now. If it is, we know we're at the beginning of the binary search tree. So we're just going to return a new node using the function we wrote up there and equating the value there. Okay, so we return that. Otherwise, actually, let's even return the node here because we're returning a pointer to the node. So we just return it here. For now, we only have expected. Oh, it's there, so that's fine. For now, we only have 100 in the node. So let's use one of those functions we wrote. So I'm going to replace this with print InOrder. And then we're going to call that print InOrder function. And then we're just going to pass in the root. All right, let's compile again. We have a warning somewhere there. Let's see what it prints. Okay, so it's printing 100. And that's print InOrder. As we start adding more and more here, I'll just call the other ones too, the other functions which are printing. The other one was PreOrder, and the other one was PostOrder. In this case, they're all going to print the same thing because we only have one value, which is 100. Okay, so those are all printing there. Let's see what this is saying, man. Control reaches end of and void function. Wait. This 32. Oh, there. I guess I can just retain 0 for now. And that warning should go away. Yeah. All right, so everything is working. Perfect. All right, so we started inserting in those values there. Now, what if the node itself is not now? So what we're going to do is we're going to check the value versus the value in the data in the node. So if the value is less than, in this case, we're going to allow duplicates. So like 100 and 100, we're just going to put it to the left. In the future, you can not allow that and just put some more logic, but let's just simplify things here. So if the value is less than the data, we know we have to go to the left. And the way we're going to do is the left dot insert. We're going to kind of like recursively all the function. We're going to pass in the left side of the function, but since we haven't used the value, we're just going to use that value in the right. So this is kind of like we are here. So we know we have 100 here, and the next value we're inserting in is 60. So to say 60 is less than that, so it's going to call insert again. I need to put 60 there. Okay, so if the value is less than no.data, why is it complaining? Okay, that's fine. That's correct. Else, we know that it's the opposite, so it has to go to the right side. And we're going to, again, call insert again and pass it in the right side. The value. Returning. Okay, why is that hints today? It's left. Okay, so the left side, we're going to insert to the left. The right side, we're going to insert to the right. And then we're going to return the node here. All right, let's see if this works. Let's go to the main function, and we're going to insert in a few values here. So we're going to insert in 60, say maybe 200, maybe 150, maybe 250, maybe 40, maybe 80. Those are kind of like the values we had in the drawing. So let's see what we get here. So the InOrder says that you print them as 40, 60, 80, 100, 150, 200, 250. PreOrder, you print the 100, which was the beginning one, and then you print the left side, which is 60, 40, 80, then the right side, 200, 150, 250, and the post order, it's 40, 150, and then you go to the 100. All right. Contains is also a traversal. You're going to kind of like recursively do it, but the video is getting too long, so I'm just going to cut that off and maybe talk about it in the future. If somebody wants to see that one, let me know. Thanks.